Welcome back, Flutter devs. This is part 7 of our Notes app in Flutter series. In this video, we'll cover how to save notes to local storage, and also using the shared preferences package for data persistence. Let's get started. Save notes to local storage. When building a Notes application, one of the most essential features is the ability to persist data, meaning that the information users input into your app remains available even after the app is closed and reopened. Without this functionality, any note a user writes would vanish the moment they exit the app, making the experience unreliable and frustrating. That's where local storage comes into play. In this segment, we'll discuss saving notes to local storage in Flutter, not from a coding perspective, but conceptually and structurally. We'll explore what local storage means, why it matters, how it works behind the scenes, the different approaches available in Flutter, and the considerations developers need to keep in mind when implementing local data persistence in mobile applications. Let's begin by understanding what local storage actually refers to. Local storage, in the context of mobile applications, is a way to store data directly on the user's device, without relying on an internet connection or cloud-based databases. This data remains intact even if the app is killed or the device is restarted. It's crucial for applications where user data must be retained between sessions, such as note-taking apps, to-do lists, and personal planners. There are various kinds of local storage solutions, each serving different purposes, from simple key-value pairs to complex structured databases. When we say we want to save notes locally, we're referring to storing the user's text input, perhaps their thoughts, reminders, or even entire journal entries, in a way that is private, secure, and readily accessible at any time. One popular way of doing this in Flutter is by using the shared preferences package, which we will explore in more detail in the next segment. But first, let's focus on the concept. Saving notes locally generally involves 3 main steps. First, we capture the user's input. In the case of a note-taking app, this input is usually taken from a text field or editor component. The content is then processed, perhaps formatted or tagged with metadata like timestamps, and finally saved into a local data container, such as a key-value store or file. This stored data is then retrievable during future sessions, allowing the user to view, edit, or delete their notes as needed. From a design perspective, local storage provides many benefits. It offers instant access to data, as there is no need for network requests or loading times. It ensures user privacy, as the data does not leave the device unless explicitly synced to the cloud. It also enhances offline usability, a critical feature for users in areas with unreliable internet connectivity or for those who prefer to keep their information strictly on their devices. However, it's important to understand the limitations and responsibilities that come with local storage. Firstly, while local storage keeps data persistent, it is inherently limited by the device's storage capacity. Developers must avoid overusing storage, especially with large or complex data formats like images or multimedia content. Secondly, security is a key consideration. While data stored locally is not exposed to the internet by default, sensitive information should be encrypted or securely handled to prevent unauthorized access, especially if the app stores personally identifiable information. The format of the data also matters. For a note-taking app, text data is usually stored as strings, possibly alongside metadata like the creation date, last modified timestamp, and unique identifiers. Developers must decide how to structure this data. For example, will each note be stored as a separate entry, or will all notes be stored in a single serialized list? These decisions influence the scalability, performance, and manageability of the app over time. Another key concept related to saving notes is synchronization. Even though we're focusing on local storage here, some apps offer both local and cloud storage, synchronizing data across devices. If that's your long-term goal, it's essential to structure your local storage logic in a way that can be extended or replaced with remote storage mechanisms in the future. For now, a solid local storage implementation ensures a reliable foundation. In terms of the user experience, saving notes locally should be seamless and instantaneous. Users should not need to press a save button in many modern apps. Instead, the app should detect changes automatically and persist data in the background. This autosave functionality adds to the sense of professionalism and reliability. Lastly, developers should also account for data backup and export options. Even though the data is stored locally, users may want to back up their notes externally or migrate them to another device. Designing local storage with these capabilities in mind ensures a more robust and user-friendly application. To wrap up this section, saving notes to local storage is not just a back-end necessity, It's a core part of delivering a smooth, trustworthy, and privacy-respecting experience in a Notes application. It allows users to focus on their thoughts and productivity without worrying about losing their data. Whether you're just getting started or looking to enhance your app's functionality, mastering local data persistence is a crucial step in building professional-grade mobile applications. Shared Preferences Package. In mobile application development, one of the most essential requirements is to store data that persists across sessions, yet does not require a full-fledged database. This is where the Shared Preferences package in Flutter becomes incredibly useful. It's a package designed to help you easily store and retrieve small amounts of data in a persistent way. While it may sound technical, think of Shared Preferences as a simple storage locker that holds tiny pieces of data, like a user's favorite theme color, login state, or in our case, Notes content. Let's begin with a conceptual overview of what Shared Preferences really is. Shared Preferences is a plugin provided for Flutter apps that allows the app to save key value pairs to disk. These key value pairs are stored locally on the user's device and are maintained even after the app is closed and reopened. The most important thing to understand is that Shared Preferences is not a database. Instead, it's more like a persistent dictionary, a simple, flat storage system for storing preferences, flags, or small snippets of information. The name Shared Preferences originates from the Android ecosystem, where this concept was first popularized. Despite the name, there's nothing inherently shared about the preferences. It doesn't mean data is shared across apps. The data is isolated to the app that stores it. The idea of shared preferences comes from the need to store application preferences or simple stateful data locally, such as whether the user has completed the onboarding screen, what their preferred language is, or in some use cases, even lightweight application data like Notes, which are mostly text-based and not overly complex. Why is Shared Preferences ideal for saving notes in our Flutter app? The answer lies in its simplicity and reliability. Most notes in a basic note-taking application are just blocks of text. Unlike images, videos, or complex relationships between data tables, simple text doesn't need the robust infrastructure of a database. Shared Preferences allows you to store a list of notes or individual note entries using keys, much like labeling folders or files on your computer. It allows quick, easy access and retrieval, and because everything is saved as key value pairs, the structure is easy to understand. When explaining Shared Preferences to beginners or non-developers, it helps to use analogies. Imagine a small filing cabinet in your office. Each drawer in the cabinet is labeled with a title, that's the key. Inside the drawer, you put a note, a setting, or a preference, that's the value. You can have as many drawers as you want, and whenever you need a particular note or setting, you simply open the drawer labeled with the right title. Shared Preferences works exactly like that. It stores data under a specific key and lets you retrieve it whenever needed. Shared Preferences supports a limited set of data types, strings, integers, doubles, booleans, and lists of strings. This limitation exists because the storage is designed to be lightweight and fast. In the case of our note-taking app, we usually store a list of strings, where each string represents a note. More advanced formats, like the lists of objects, would require serialization, but Shared Preferences still handles them efficiently after converting them into acceptable data types. Now, let's dig deeper into the lifecycle and management of data within Shared Preferences. When your application starts, it can read existing values from Shared Preferences to determine what state it's in. For example, it can check whether any notes already exist, and if they do, display them to the user. If no notes are found, the app knows it's the user's first time, or all notes have been deleted. When the user creates a new note, your app captures that input and writes it into Shared Preferences, tagging it with an appropriate key, say, Note1 or Note_list. The next time the user opens the app, that data is pulled from Shared Preferences and displayed automatically. One of the biggest advantages of using Shared Preferences is its speed. Since it uses local device storage, reading and writing to it is extremely fast, ideal for small datasets like text notes. Users won't experience any lag when opening the app or when saving a note. It all happens seamlessly in the background, enhancing the overall user experience. Another important aspect to consider is data persistence. Data stored in Shared Preferences doesn't vanish when the app is closed or even when the device is restarted. This makes it dependable for saving stateful information or content that should always be there unless the user chooses to delete it. In our Notes app, this means that once a user writes a note, it stays on their device indefinitely, unless they delete it or uninstall the app. Let's also talk about platform independence. One beautiful feature of Flutter and its ecosystem is that it supports both Android and iOS with a single codebase. The Shared Preferences package takes care of platform-specific implementation under the hood, providing a consistent interface for both platforms. This abstraction means you don't need to worry about whether the user is on an Android or an iPhone. The data will be stored and retrieved seamlessly regardless. While Shared Preferences is incredibly useful, it's also important to understand its limitations. It is not designed for complex data structures or very large amounts of data. Trying to store thousands of notes, each with images or attachments, can lead to performance issues. For such use cases, a local database like SQLite or Hive is a better fit. That said, for small to medium-sized apps focused on plain text, Shared Preferences strikes the perfect balance between simplicity and power. Security is another concern. Shared Preferences stores data in plain text by default. While it's not publicly accessible to other apps, a rooted device or malicious user could potentially access this data. For secure information like passwords or tokens, developers should either encrypt the data before saving it or use more secure storage options provided by packages like Flutter_secure_storage. However, for basic note content, especially in personal or casual apps, this level of security is often considered acceptable. A few good practices to follow include: always structure your keys thoughtfully to avoid collisions or confusion. Keep your keys constant and documented to ensure consistency across your app's lifecycle. Avoid storing data you don't need to persist. Every write operation has a cost, albeit small. In a well-designed Flutter app, Shared Preferences becomes the bridge between your app's user interface and its memory, ensuring that what users create or customize doesn't disappear. It empowers even small apps to feel complete and reliable, and allows developers to prototype and deploy meaningful features quickly.